All right, in this video, we're going to look at listing the terms of a recursively defined sequence. So in the last video, for explicitly defined sequences, we could just plug in different values for n or whatever our variable was, and it would generate our terms. So if we, let's say, wanted the first four terms, and let's start with n equals 1, we can plug in n equals 1 to get the first, n equals 2 to get the second, etc., until we get the terms that we need. Well, that's one way to generate the terms of a sequence or the list of numbers. Another way is to generate them recursively. So a recursive sequence is one that is defined using previous terms. So you'll be given a starting term value and then a rule for generating additional terms. And then you can use that rule and apply it to each, your starting value to come up with the next value. And then the value after that will be based on maybe one or more previous values. So our notation for successive terms, if we have a sub n, the next term after that is going to be a sub n plus 1. Or sometimes we also will have a sub n minus 1. The next term after that is a sub n. So for instance, let's say this is a sub 5. The next one would be 5 plus 1 is 6, a sub 6. Or if this is a sub 4, where n minus 1 is 4, so that'd be 5 minus 1 is 4. A sub 4, the next one after that would be a sub 5. We just add 1 to this subscript to get the next subscript. So add 1 to this n to get n plus 1, add 1 to n minus 1 to get n. So example 2, write out the first four terms of each sequence. We have a sub 1 is 5, so our initial term is 5. And our rule, a sub n, is 3 times a sub n minus 1 plus 2 for values of n that are going to be greater than or equal to 2. Now, recursive sequences can be a bit tricky, but one strategy that I use is to look at the rule for the recursive sequence and then rewrite it in terms that are easier for me to understand. So a sub n is each new term, and typically with recursive sequences, each new term will be by itself on the left-hand side, is going to equal a sub n minus 1 is the term right before a sub n. So a sub n minus 1 is the previous term or the previous term value. We're going to multiply that previous term by 3 and then add 2. So we're going to start with 5, and then each new term we're going to take 3 times that 5, or the second term we're going to take 3 times the 5 and add 2 to it. So starting with 5, our next term, a sub 2, is going to be 3 times that 5 plus 2 is 17. Now the third term, we're going to take this answer, this is our previous term now, we're going to take this answer of 17, multiply it by 3, and then add 2 to that result. So each new answer we input into the rule again, and we come up with a new answer. So 3 times 17 plus 2 is 53. Take this output, put it in back into the machine. 3 times 53 plus 2 is 161. So our first four terms are 5, 17, 53, and 161. A recursive sequence is nothing more than compositions of functions where we take the outcome of a function and plug it right back into the function itself. So this function's job is to take 3 times whatever you give it and add 2. In this case, we're going to give it the previous value each time. So we're going to put in a 5. 3 times 5 plus 2 is 17. Put that 17 back into the machine. 3 times 17 plus 2 is 53. Put that 53 right back into the machine. 3 times 53 plus 2 is 161. So again, recursive sequences are compositions of functions where you're just taking the output and putting it right back into the function itself. All right, we have part B. First term is 7, and then we have each new term. Now we're using a sub n plus 1. Each new term is 2 minus the previous term. So each new term is 2 minus the previous term. So we're starting with 7. The new term is going to be 2 minus 7, which is negative 5. And then the next term is going to be 2 minus the negative 5. So take this, put it right back into the machine. 2 minus negative 5 is 7. And then the next term after that, 2 minus 7 is negative 5. So as you can see, we're just alternating between 7 and negative 5 each time. So, if I asked you what the 1,000th term is, 1,000's an even number, so that's going to be the negative 5 output. If I ask you for the, I don't know, 83rd term, that would be 7, since 83rd is an odd number. So sometimes it's quicker to pick up on patterns after a few observations. All right, part C, we have f sub 0 is 1, and we have f sub n is n times f sub n minus 1. So this time we not only have the previous term, but we also have the term number that we're on. So this one might be helpful to make a table for, but each new term is going to be the term number, that's what n represents, times the previous term. So we're going to start with when our first one here is 1. And then our second one is we're going to take the term number, which is 1, this subscript, multiply it by the previous answer, and we get 1. Then f sub 2, we're going to take the 2, that is our subscript, and multiply it by the previous answer of 1, we get 2. F sub 3, we're going to take 3, that subscript, times this previous answer of 2. 3 times 2 is 6. We got the first 4, but if we kept going, f sub 4 would be 4 times this 6, which is 24. Then f sub 5 would be 5 times that 24, which is 120, and we keep going and going from there. But for this one, we have 1, 1, 2, and 6. So, all right, that about does it for this video. Thanks for watching. I'll see you next time.